Hey guys, welcome back to another video. Sorry it's been a long time since I've uploaded. I had a project that I was working on, and I was planning on making a video out of it, and upon further examination of my footage, I found out that most of my footage was corrupted. Wonderful. So unfortunately that video is not going to be coming out. Maybe some of the uncorrupted footage that I got I'll roll into a clip, but right now there's just not enough there to really make a video out of it. So that's been part of what's been going on. I also ended up catching coronavirus there, so I was out for those 2 weeks or so in quarantine. That was less than enjoyable, and really didn't want to be trying to make videos while being just that sick. So anyway, but we're back, and as you can see, I've got some aluminum here in front of me. About 2 videos ago, I talked about some things that you should know before you start TIG welding, and this is going to be a continuation on that. We're going to start with TIG welding some aluminum here, and so we're going to go over some of the things that you need to know about this metal in specific. And I want to go over this stuff because a lot of beginners won't know kind of what to expect on aluminum. So I want to explain some of the properties of aluminum so that you can kind of use that to your knowledge to get better at welding it. And then we will go over some of the machine settings, and hopefully we'll be running a bead later here today if I can find a nice spot to put the camera in where it can actually see everything. So let's dive on in. Okay, so first thing that you should know is the current that you are going to be using when you are TIG welding aluminum. So aluminum runs on an AC current, and for those of you who have seen my AC stick welding video, this should look pretty familiar. But for those of you just coming in, AC stands for alternating current. So this is your direct current negative side and your direct current positive side. And this is basically which direction the electrons are flowing. So when you're on the negative side, your electrons are flowing from your electrode. In the case of TIG, that would be your tungsten. So it goes from the tungsten and down to the plate. That is the DC negative side. So from tungsten to plate. On the positive side, what happens is the current flips, the direction flips, and your current comes from the plate up to your tungsten. And that's basically what that means. So here you can see a more or less traditional AC waveform here. The old school machines would only ever run this, and you know, it works. It got the job done. So this line here in the middle is a 0 point, that is 0 amps. And then the peak up here is supposed to be your maximum amperage. So you go from 0 to, say 100 or so, you know. So you go from 0 to 100, and that's from electrode to the workpiece, in this case our aluminum plate. So from the tungsten to the aluminum plate, and then the current flips, hits a 0 point, and then it would go 100 amps on the other side of your current flowing from your workpiece, in this case the aluminum plate, up to your electrode, or our tungsten. So that's what all of this means. Now, let me grab my pen here. From this point to this point. Okay, so that is one full cycle of the wave. Okay, let's see, let me swap my hands here so that I can kind of right here. So from here to here. This is 1 hertz, right like that, okay? 1 hertz, and traditionally, the way that we measure things out in welding terms is that you will have 60 hertz per second. So for every second that goes by, you will have 60 of these blocks in the waveform. That's what that means. So remember the hertz, we're going to get back to that in a bit when we go to start setting the machine. But anyway, so this is your traditional AC waveform that is used on AC stick welding and old school aluminum TIG welders. Now, the newer TIG welders will run slightly different AC waveforms. So the first one here, this is a square waveform. So as you can see, what the square waveform does is it picks you up to your desired amperage and holds you there, and then it does an immediate flip with almost no time in between. This is much more stable and it'll help you in your welding. So you can see that in the hertz section there, you don't spend any time ramping up and ramping down. It's just immediate 100 amps DC negative side to 100 amps DC positive side. So it makes the flip really, really, really fast. Again, at 60 hertz a second. The next waveform that's used, this is called a soft square wave, and my drawing here doesn't quite do it justice, but basically it's the same as the square wave, but it's got a soft curve right at the top. So for sake of argument, this might not always be correct, but just for demonstration, basically what will happen is, say this is set to 100, you'll jump up to like 90, maybe 95, and then you'll have a soft arc of the last 5 amps within that hertz cycle on each side. This is much more stable and a lot cleaner. It gives you a lot more control than just the traditional square wave. So most newer and modern machines will use this waveform. That's not to say that you can't switch between them on all machines. Some machines have the functionality to switch between these different waveforms, but most of the time expect to be welding with this waveform on newer machines. And the last waveform here, it's a triangle waveform as I've put it. As you can see, it spikes up to its peaks and valleys very quickly. It does not spend a lot of time at max amperage. This waveform is for your sheet metal, for your really thin metal, because you're trying to not spend too much time at peak amperage so that you're not dumping a ton of heat into your part. So that's why this waveform exists. And those are kind of the waveforms. Now, the next part that we got to start talking about is balance and hertz controls. Okay, so AC balance. So on this first waveform up here, this is 1 hertz of that waveform. So as you can see, I've got my negative side and my positive side. And now in this particular waveform, these are equal, okay, at 50%. So this is called balanced welding, okay? You have the same amount on the negative side as you do the positive side. Adjusting your balance will start shifting your waveforms like these two down here. Ignore my wonderful drawing right there. So, as you can see on this first one, okay, negative side on the top, positive side on the bottom. What's happened here in this hertz, this 1 hertz, is we have adjusted how much time we spend in each polarity. So, on this particular one, we are, this is all kind of theoretical and not mathematically correct, but we are essentially a 70% in the negative side and a 30% on the positive side of that hertz. And remember, we're doing 60 or more of these per second, okay? So, and then on the reverse side, this is the opposite of that. So, we are a 30% on the negative side and a 70% on the positive side. Now, let's talk about this. Most of the time, you're going to want this kind of a split, more favoring the negative side than the positive side. Reasons being, the negative side is your heat into the plate. This is what makes your plate melt. The positive side is what's known as cleaning action. And this will be a good kind of spot to touch on this, I guess. On your aluminum, what aluminum does is it forms what's called an oxide layer on the top portion. If oxide sounds familiar, iron oxide is what we know as rust. Now, aluminum oxides are not quite the same as rust, but for the purposes of this video, kind of think about it that way. So, rust will kind of stick to the surface of your steel, and then if it starts to get really bad, it starts to spread throughout your steel. Kind of the same with aluminum. However, aluminum rust, if you will, does not go below the surface, or it shouldn't be going below the surface. But we need to remove that layer of oxides in order to weld this stuff. Reason being, the oxide layer that's on the surface of this melts at, let's say, about 3,000 degrees Fahrenheit. Okay? The aluminum underneath that oxide layer will melt at about 1,600 degrees Fahrenheit. So the oxide layer melts at about double what the aluminum will. So we need to remove that oxide layer somehow in order to get down to the aluminum and actually weld it. So that's what the positive side of your AC arc is for. What this does is as the arc comes through the plate, jumps from the plate to the tungsten. Okay, remember, the positive side is from plate to electrode. So, from the aluminum to the electrode, as it makes that jump, it will blow the aluminum oxide layer out of the way. And then we can come in with the positive side, the heat side of our arc, and melt the aluminum underneath, which allows us to weld. You'll notice on this one, you see that white line right onto the edges of the weld that run all the way across? That is what's called an etching line. That is what the positive side of your arc is doing. It's moving all the oxides out of the way so that you can weld to the aluminum underneath it. So, that is why you want balance. Now, this one is more like if you're welding really dirty aluminum that you got to move a lot more stuff out of the way of, so that you can get down to your aluminum. However, this is also worth mentioning. The more into the positive side of the arc you go, the harsher it's going to be on your tungsten. So, when people are talking about balling up their tungsten, and that's kind of a old machine thing. Old machines run on this balanced setting. So you have the same amount in the positive, and the same amount in the negative, positive. Hopefully I can keep those straight. You got the same amount in both. It is this positive side that balls up your tungsten. That's what makes the tungsten a ball. Now, as your tungsten balls up, it is going to widen the cone of that arc. So, the more balled up your tungsten is, the wider the cone of the arc is going to be. That can lead you to some troubles when you're trying to do precision aluminum welding. So, most of the time, you're going to be in basically this mode, kind of give or take depending on how clean your aluminum is. So, you want your balance to favor your DC negative side. This will help keep the tungsten mostly pointed and give you a much more focused and controlled arc. And that's why you want to use this side. So, that should be kind of an overview on balance there. One thing I will say is when you get to welding, you're going to have to play around with this setting a little bit so that you can find the one that works for you. Now, let's go ahead and talk about hertz controls. Okay, so basic overview of hertz and hertz control. So obviously this is not quite to scale, but you know, if I were to really put down 60 hertz, I'd probably need a paper as long as my workbench here. But anyway, so a hertz all comes back to how many times your waveform switches back in 1 second. So for the sake of theory, we'll pretend that this is 60 hertz a second. So there's supposed to be 60 switchbacks per second. And by switchbacks, I mean coming back to that polarity that you started on. So negative, positive, and back to negative, that's 1 hertz. So technically this graph here would be 2 hertz in 1 second, but welders like to run at 60. 60 is your baseline. So a lot of newer welders, you can adjust the hertz. So technically on paper, this would be a 1, 2, 3, 4 hertz per second cycle. But we're going to pretend that it's 120. Just imagine these keep going. So this is what hertz control is how many times excuse me, is how many times you do those switchbacks in 1 second. So 60 hertz won't have as many switchbacks as 120 hertz. Now, the reason that this is kind of nice, the less switchbacks you have, the wider and hotter your puddle will be. So this tends to dump quite a bit more heat into the plate, especially when you balance it out. Okay, so the wider your bead will be, the hotter it will be. So lower hertz generally used for welding thicker aluminum, stuff that you got to put some heat into in order to get it to weld correctly. Whereas as you increase your hertz, you spend less time at your peaks and you have more 0 points. So it concentrates your heat down, giving you a more narrow, I don't want to say controlled, but a more narrow and concentrated bead. Concentrated, that's a better word for it. So more narrow and concentrated, much better as you start getting thinner and thinner on your aluminum. A bit more wide and a bit more heat into the puddle as you get into thicker aluminum. So that's kind of the general concept with hertz controls and why you want to use them. Now, in my experience, I like to run anywhere between 90 and 120 hertz for just about everything. Because the other flip side of this is, because the hertz are wider on your lower side, you'll spend more time, even if you balance this out and get that 70% negative, 30% positive, even as you balance it out, you'll still be spending more time in that positive side, which again, balls up your tungsten and makes the arc get wider and wider. And it gets harder and harder to keep it controlled and pointed where you want to go, which is ironically the main criticism of most old TIG welding machines. So if you keep your hertz higher, you won't run into that situation where your arc keeps getting wider and wider because your tungsten keeps balling up. It'll help keep your tungsten shaped better so that you can make a more controlled and precision weld. So that's the other point with hertz. So the hertz and balance all work together, and you can do a lot of different things with your AC arc on the newer machines that can help you tackle a whole bunch of different welding applications. So let's go ahead and we'll head over to the machine, and I'll show you the settings that I'm going to use to run a bead on this plate. Okay, so here's my machine. Sorry about the machine noise, but it is what it is. As you can see, my light is set to TIG aluminum. And on the Everlast, this is what it looks like. Now, don't panic. I know this is a lot, but we're going to walk you through it. So, first setting right here. This is my amperage setting. You'll see that it says 20. The way Everlast likes to do their stuff is they'll tell you what your starting amperage is, or just kind of where it's sitting, and when you go to adjust it, then it will flip back to your set amperage. So for that piece, I'm going to set this to the max that my machine will do, which is 200. And then it should swap back. Yep, there it goes back to that 20. Okay, so that's just kind of telling you where it's going to start, where the machine starts. And you'll notice I've got a starting amperage control that I've set to 20 and an ending amperage control that I've set to 20. Most machines will kind of do this stuff automatically. I'm going to go ahead and change that start amperage. Just because sometimes this machine can be a little bit finicky on some of that stuff. Okay, so I'll just go ahead and change that. Go through. So my machine has a pulse function. We'll probably get into that some other time. Up slopes, down slopes, probably don't need to worry about. Okay. Now, you'll notice that this has an AC on function. Now, when I go into the sub menu for this, and for any of you guys who have Everlast, this will be a good little tutorial how to set this thing, because it can be pretty intimidating, all these different screens. So, here is my AC wave control, basically. So you'll notice over here, I've got a square wave setting, I've got a soft square setting, and I've got that triangle setting. The last project that I was doing was a pretty thin piece of aluminum, 16th inch, so I had that on the triangle. Now I should, okay, so this knob changes the frequency, the hertz controls. So for this one, I'm going to go about 90 hertz on this one. And then my balance, I had it set at 40. I'm going to go ahead, okay. Let's talk about this real quick. You'll notice that my balance says 30%. The way that this particular machine measures out the balances is this is your percentage of positive. Okay, so I have 30% positive, 70% negative. The millers, so if you have a miller, most millers measure in negative. So, most millers you will set to 70% because that is 70% negative. Again, my machine reads in positive, so I'm going to set mine to 30%. Pay attention to stuff like that. Get out your manual, make sure you know what this number means, whether it is telling you its percentage in positive or its percentage in negative. If you don't know, if you do not know, keep it between 45 and 55. Dead serious. Keep it there if you do not know, because you can run yourself into some really serious problems if you're not sure. So anyway, 30% positive side, 90 hertz, it's a little bit of a thicker plate, and we are going to go ahead and use the soft square wave, which is kind of my favorite. So there's that. And okay, back to that. So again, it says 20, but the set amperage is 200. Let's see, go through the rest of these. So control. I've got a pedal, so I've set mine to pedal. Some machines give you the option for pedal. I also have a finger torch. I don't really use it that much. It acts a little weird. The 2T and 4T we're not really going to worry about. This is basically just how it triggers. If you have a machine that kind of combines the pedal and the 2T, 4T, basically what you need to know, the 2T is a 2-trigger system. So what that means is when you push the pedal down, it will arc, and you can adjust it with the pedal. It will go all the way up and all the way down, all the way up, all the way down throughout the whole range of the pedal. 4T is a 4-trigger system, which essentially means hit the pedal twice and it will start the arc, ramp it up, hold it while you weld, and then you'll hit the pedal again 2 times and it will bring the arc down and shut it off. So that's kind of what that's for. But I'm just going to leave mine on pedal control. Technically it's a 2T pedal control. but we're not going to worry about it. This is one area where Everlast is programmed a little weird, so I'm just going to leave it on pedal control. Next part, arc start. Okay, so HF stands for high frequency. Okay, this is also a good note. Some machines you have to tell to manually continue the high frequency. Okay, so a lot of older machines will have an HF start and an HF continuous. If you are in AC mode, welding aluminum, you need HF continuous. Okay, that means continuous high frequencies. And the high frequencies are to do with that 0 point in the arc. It's to keep your arc lit as it's going through that 0 point, which is why AC TIG works a lot better than AC stick. So just remember that you need a high frequency continuous. Lift arc, you're not going to, I shouldn't say that you can't use it in AC. You can, actually I'm thinking scratch arc, so you can use lift arc. The thing is that most lift arc applications, you're worried about high frequency, so you're probably not going to be welding aluminum. But so the way lift arc works is you'll touch your tungsten to the workpiece, hit the pedal, and then lift off the workpiece to get your arc to go. It's mostly used if you're working in like an electronics kind of assembly where the high frequencies can screw up your electronics. So it's not most common, but it is out there, and I don't see too many times you might be using aluminum in that kind of setting, just because you need the high frequencies on the continuous to weld the stuff anyway. So, but anyway, little tangent there, not too much to worry about. Next thing. Oop, wrong way. Okay, Postflow. Let's talk about Postflow when you're TIG welding. You can see here, I've got mine set to 6, and that's 6 seconds. So I can adjust that however much I want. Does this have an auto function on it, I wonder? No, it does not. Okay. So some machines will have an auto function. If you're not too comfortable setting your post flows, that's all right. There's an auto function. This one doesn't have an auto function. Now, the way you want to think about it, and this is in regards to aluminum. It's a little bit different for stainless, but steel and aluminum, actually let's just say aluminum, okay? So, in regards to aluminum, the big point that you want to make sure on the post flow is that when you shut off your arc, grab my torch here, okay? When you shut off your arc, your tungsten is going to be red hot. You want enough post flow coming out that your tungsten will cool off from being red hot and back to normal color before your post flow shuts off. So you should have gas flowing on your red hot tungsten at all times. And that's kind of how I set post flow with aluminum. Now, the metal itself, let me set that back up there. The metal itself, maybe if I can get this back into focus. Anyway, aluminum itself is what's supposed to be called a non-reactive metal. That's true to most extents, but keep in mind if you heat up aluminum too hot without shielding gas, you'll get a reaction out of it, okay? But it's supposed to be a non-reactive metal, so post-flow isn't the biggest deal, but yeah, anyway, you don't really need to shield your weld after you get done welding with aluminum. So, there's an overview of all the settings. Let's go ahead and see if we can run a bead. So before we run a bead, in classic Weld and Eldon fashion, I want to have a moment and discuss technique. Now, one of the reasons that TIG welding is largely considered one of the hardest kinds of welding to learn is there's a lot of technique that goes into it, from the metal to the torch to your filler rod and how well you can get your hands to work to actually, manipulate the filler rod. So let's go over some of that real quick. So as you can see here, I've got my filler rod in my hand. First thing that I tell people when they're trying to get better at TIG welding is learn how to move your filler rod. You've kind of been seeing it on camera. So I like to hold my filler rod between my middle finger and my ring finger. Okay, creates a clamp, and then I use my index and thumb to kind of create a clamp on the back. And what I do, and there's a whole bunch of different techniques, this is just what I do. So if you find a way that works better for you, by all means do that. You don't have to do exactly what I say, but I'm going to show you what I do. So as I get going, I will use my middle two fingers to extend, release with the thumb, clamp with the thumb, bring the fingers back in and extend it out. And this is how I fill my rods. Okay, I can do a little bit of thumb action there. I can move it back and forth. I have spent more hours than I care to admit learning how to do this. Sometimes I like to just use my thumb. So I'll kind of bring it in, bring it out, bring it in, bring it out. And just sit down with a filler rod and just kind of learn the motions so that you can accurately and easily manipulate your filler rod to get it to do what you want it to do. So I guess technically I'm actually using my thumb a lot more. It's hard to sit down and explain something that you know by instinct, but as you can see I actually use my thumb quite a bit more to get the fill in. Okay, so that's just how I do it. There are some people who can kind of like roll it down, so to speak, kind of like this. I'm not the greatest at it, so I kind of prefer to do it like that. So anyway, there's a whole bunch of different ways to do it. That's the way that I do it. Now, that's the filler section. The other thing that you got to keep in mind is down there, I have a pedal. So I like to foot control pretty much all of my welding. Bring this up here. And this is the other really, really difficult part with TIG welding, is that you have to learn how to manipulate that pedal. So this pedal, as you kind of saw when we were setting it there, when I push it down, it gives me arc and a certain amount of amperage. The more I push it down till it reaches full, the more amperage I get. That's basically how the pedals work. It's kind of like a gas pedal. The more you get it, the more you'll get. Okay? That's how I have mine set up. A lot of the skill and technique involved in TIG welding is learning to work that pedal. And I'll be honest with you, there's no magic explanation. There really is no magic explanation. You are going to have to sit down and spend hours learning how to work that pedal, learning how to read the puddle that it gives you, and learning what welds correctly and what doesn't. So it's these reasons are the reasons why TIG welding is so difficult to learn. Is there's a lot going on. You're using both your hands, one of your foot, and everything's got to be working in sync. So now on the torch side, let me go ahead and grab my torch here, my big honking torch. What I'm doing, and a lot of this is learning to read the puddle, okay? So I'm going to be hitting roughly about like that. I'm more focused on the bottom plate, and if you can see it, I've got to work with the camera here. So I'm going to be slightly focused on the bottom plate, and I'm going to roll it up. If you can kind of see, I'm going to roll it up to the bead, and then I want the center of my weld to be right along the edge of that bead there. So that's kind of the plan with that. You want to kind of go in straight and then give yourself a bit of a lead angle like so. So you want to be pushing your gas to the next area that you're welding is the idea, okay? Be pushing your gas to the next area you are welding. So that's kind of the technique moment there. This is a little tight. It might be hard for me to film in, so I think I'm going to flip this plate over. And we'll go ahead and run a bead. And voila, that short bead there is the one that I just ran. It came out all right, all things considered. I could sell that. I kind of ran it on top of this big long practice bead when I was, getting stuff set up. But there you go. Actually came out all right. So that's TIG welding aluminum. So hope you guys enjoyed. Hope you learned something. One thing that I would like to point out, you might have noticed when I was running that bead that when I was adding in the filler, it kind of looked like I was filling on kind of a weird wonky angle. I was actually coming in this way to do my filler. Now, this isn't necessarily the proper way to do it, but I wanted to try and keep the filler rod and, in extension, my arm on that side out of the way of the camera shot so that you guys could hopefully actually see something. So anyway, this is one of those do as I say, not necessarily as I do, because the things that I do, I need to do to kind of make concessions for my setup and whatnot. But anyway, there's an aluminum bead for you. Hope you guys learned something, and we'll see you guys in the next one.